In this video, I'll show you how to run a hypothesis test for a population mean. So in discussion board 4, you're going to be creating and conducting a hypothesis test. You get to choose if you want to do a mean or a proportion. And so in the instructions, I have hyperlinked worksheets that you can use to guide your process. So if you click here on the hypothesis test of a mean, it will take you to a Google Doc here that has all the steps. And to download your own copy, you'll go to File, and then you can make a copy into your own Google Drive, or you can download a Word version, whatever you prefer working in. I'm going to go ahead and download a Word version. Now keep in mind, depending on your device, when you download the file, especially if it's into a Word or Excel or anything, you might get a yellow banner up at the top that says Enable Edit. Make sure to click the Enable Edit button so that you can actually do things with the document. But anyway, here I am. The way I have the worksheet laid out, it has all of the components for you set up, so you just have to go through it step by step. And again, this should feel very familiar. You did this in chapter 9. We're just now doing hypothesis testing with the project data as opposed to data from the textbook. So if I go back to our discussion board 3, you'll recall that I already ran a confidence interval estimate for price. There's my mean, there's my margin of error, I've got a sample size, and I had found my upper and lower limits for the confidence interval. With this data, I'm going to use the same information in order to test my hypothesis. So I'm going to be conducting a hypothesis test on the average price per night in Ville Marie, which is a neighborhood of Montreal where I'm considering opening a bike and wine tour. Specifically, I want to know if Ville Marie is greater or less than 181 Canadian dollars. And that's because according to Budget Your Trip, I did some research in there, and that's what they told me was the average price for the city or the area of Montreal. So I'm choosing this hypothesis test because I want to market my bike tour of wine bars and breweries in an upscale neighborhood. And I think Ville Marie fits that description, but I need to know how it compares to Montreal as a whole. So I'm going to be setting up my two-tailed hypothesis test like this. My null hypothesis states that the population mean is equal to 181 Canadian dollars per night on average. And again, I got that from this website here, budgetyourtrip.com. And then the alternative states simply that the population mean does not equal to 181 Canadian dollars. So I'm on my worksheet here, so I'll go ahead and say, hey, my mean's going to be the $181 from the internet. And as you type, you'll see that the things kind of move a little bit, but you'll just want to adjust and maybe delete some extra spaces. Whereas my alternative says it doesn't equal to 181. And here on the, if I go to the Insert tab, over here on the right, there's an option for symbol, and there's the symbol for not equal to. If you can't find it, you can also just type out the words not equal to remind yourself. But I'm going to go ahead and do the not equal sign. And again, it's still 181. The 181 is a hypothesized population mean that I got to choose, and I found it on the internet. So I do have that reminder down here. You get to choose what the hypothesized population mean mu is. You also get to choose the alpha or significance level. So I'm going to choose 0.05 because that's the most commonly used one. You can also choose, 1% or 0.01 or 10%. That's 0.10, or, you can get creative and do 2% and change stuff up. But I'm going to do 5% because that's the most commonly used one. Now for the sample size, sample mean, and sample standard deviation, you already have that from the confidence interval estimate. So if I go over to my confidence interval estimate, let's see, I had a sample size of 1670. So let me go ahead and write in 1670. And I had a sample mean of 230.92. So 230.92, and my standard deviation, so that's this one right here, is 232.77. So be very careful that you find your standard deviation correctly. It's spelled out right there. Sometimes students use the wrong number, sometimes they use the standard error, which is not the same thing. So please use the standard deviation. So I'm going to do 232.77, and you know what? I'm going to double check Those are all my correct numbers. 230, 92, 232, 77, 1670, all good, okay? Now, because I'm doing this as an equals, not equals scenario, because I don't know, is it more, is it less? To be safe, I'm going to go ahead and do the equals, not equals, which is a two-tailed test. So I'm doing a two-tailed test here. And that means when I go to part A here and I need to set up my critical values, I have three options, right? There's the two-tail test, the lower tail test, or the upper tail test. I'm doing a two-tail test, so I'm just going to go ahead and highlight this so I don't forget that's what I'm working with, okay? Now, for the degrees of freedom, that's just n minus 1. My n was 1670. So 1670 minus 1 is 1669. Okay, so I am setting up all my variables to what I need it to be. To find my decision rule, so these are the critical values of when I'm going to reject the null or not. It says we reject the null if the test statistic t is less than the critical value blank. That's on my left side, so it's going to be a negative critical value, or greater than the critical value blank. So greater than means I'm on the right side. That's going to be a positive critical value. Otherwise, do not reject. And right here, I give you the formula that you need to find the critical value t. So it's this one right here. So what you can do, for instance, so I need to find my critical values. So I'm just going to use the formula that I have provided on the worksheet there. So equals t.inv.2t parentheses. The alpha I chose, that's the 0.05. And my degrees of freedom, I found right here, which was my n minus 1. So that's 1669. Close parentheses and hit enter. So my critical value is 1.96 and a bunch of numbers. So I'll go ahead and just round down, to 2 decimal places for my critical value. So remember, Excel can only give me one number, but I know I have to do 2. There's going to be the negative 1.96 for my critical value on the lower side and my positive 1.96 for the critical value on the right side. So I am setting up my hypothesis test by finding out the critical values. Okay, now let's do part B. We need to calculate the test statistic. So recall a test statistic means I'm taking all my variables, I'm plugging it into some formula, and I'm turning it into something that I can test. So I always give the example of like cooking. You got to taste test your food. So you got to put all the ingredients together and cook it or bake it, and then try and taste it and see if it tastes good or not. So here I need to take my sample mean minus my population mean on top. So my sample means the 230, 92, minus the population mean, which I hypothesized from the internet website as 181. And then in the denominator, I'm going to take my sample standard deviation and divide that by the square root of n. So my 1670. Let me just move this over a little bit. So now you can see I just put in all my variables where they belong. And then I'm going to solve the top and the bottom carefully. And I'll show you how to do this in Excel. So just, so you can see the, let's do the top and then the bottom, just so you can see, right? So I'm going to take my sample mean of 230.92 minus the population mean of 181. That gives me 49.92 on top. And for the bottom, I'll do my standard deviation of 232.77 divided by the square root of 1670. And I'll close parentheses and hit enter. And let me go ahead and round that a little bit because I don't like all those decimals. So that makes it a little bit cleaner at 5.70. And then to actually get the test statistic, I'm going to take my top number and divide it by my bottom number, right? So in this case, I am clicking on the numbers that I want. So I'm taking 49.92 divided by 5.7. So I'm taking these two numbers and dividing them by each other. And that gives me a test statistic of 8.76. Okay, so there's my 8.76. Again, if I'm here in Excel, you can always use the arrows to do the rounding for you so that you don't make any errors in rounding. So yep, there's my test statistic right there. We have to do our conclusions based on two methods, and they are going to match each other. If they don't match, you know you've made a mistake. So let's do my conclusion per the critical value method. So imagine I've got my lovely bell-shaped curve, and I have my critical values on either side, the negative on the left and the positive on the right, and I need to compare. Where does 8.76 fall on that curve? And now because 8.76 is a positive, and I'm just going to put a plus sign so we remember it's positive, I'm going to compare this positive test statistic to my positive critical value, right? Because I'm on the right side of my curve. So I'm going to do how does 8.76 compare to 1.96? So because my test statistic of 8.76 is greater than my critical value of positive 1.96, because right, 8.76 is bigger than 1.96, right? Just by numbers, this number is bigger than that number. If I imagine the curve, I'm in the rejection region. I will reject the null. And if you want to, make the subscript, that's the little button right there. So yep, we're going to go ahead and reject the null. Then if I do the conclusion per the p-value approach, again, I've got my formulas here depending on what kind of tail test I'm doing. Recall I was doing a two-tail test because, I've got the equals, not equals. There's two chances of getting rejected, the left and the right side. So I'm going to go ahead and use this formula here. So let's find the p-value. So I'm going to do equals t.dist.2t parentheses. Now, the x here is my test statistic. That's that 8.76. Be very careful. When it asks for the x, that is the test statistic that you found in part B. Sometimes students make the mistake and they accidentally put the critical value in there, which doesn't make sense. You need to put your test statistic. So I put in my 8.76, and then I put in my degrees of freedom of 1669. And you're like, where did that come from? Recall we found it earlier up here, my 1669. I'll close parentheses and hit enter. And I notice I get a really weird number because remember, p-values are probabilities. Can I have a probability with a letter E and a 4.6? Nope, that's not possible. Probabilities have to be between 0 and 1. So this right here tells me this is in scientific notation. So if I go to the numbers tab, the easiest way to clean this up is to just click on the comma style button, and that will turn it back into a normal number. And then I can just double check, go out 4 decimal places. Wow, it's really small. If I go out even more, I don't know, let's see, how small is this number? What are the odds? Wow, so tiny, right? So like lots of zeros in there. But I'm just gonna, keep it rounded out to 4 decimals. And so we'll say because my p-value of 0.0000 is less than my alpha, and again, we chose the alpha, which was 0.05. And I can also say alpha of 0.05. We are going to reject the null. And let me just subscript that. Okay. And if you forget that decision rule, I have it right here. If your p-value is less than the alpha, we reject the null. Because remember, the p-value, that probability, it means the probability is so small, it fit in the rejection region. It fit in the alpha. It fit in the tail. And so my p-value is definitely tiny, really small odds, but it fit in the rejection region. So we are going to reject the null. And that's how you run a hypothesis test for a population mean. Now, just some reminders. When you are submitting your discussion board 4, sure, you've done all this great math. You need to make sure to explain a couple things. Explain how you decided on that hypothesized population mean. For me, it was a website, but it could be expert opinion. Maybe you are an expert in that city and you know what the typical prices are, so you can offer that. You can also offer a conservative number. Maybe you're wanting a particular budget of people and you know what that number looks like. So you just have to be able to explain it. Okay. And then more importantly, what are the implications of your conclusions in part C and D in terms of the business decisions? You need to explain the so what. So what if we're rejecting the null, right? And so take a look at the discussion board. I do explain the interpretation behind this. And if you've got any questions, just let me know.